Before starting the lesson, see if you can try this warm-up. Bob needs to ship a Christmas present to his grandpa and must decide between two delivery companies, Donnie's Deliveries, Susie's Shipping. Use Desmos.com to graph each relation on the same graph and then determine what type of relation are these. So pause the video, try these questions, and then come back and see how you did. So when you use the Desmos graphing calculator, you'll get something that looks like this. Donnie's Deliveries starts at a lower price, but rises faster as a higher rate of change. Susie's Shipping starts at a higher amount, but has a lower rate of change. Okay, so you get something that looks like that, and you can see that these relations are linear. You know they're linear because they give straight lines when you graph them. And this leads into our lesson, comparing graphical models. Remember, graphical models are graphs that model the relationship between two variables. So we're going to compare different models, different graphs. Okay, so by comparing them, we're going to be able to compare them by analyzing initial conditions. So we'll talk about what initial conditions are, and rates of change, which we talked about in the last lesson. So first, some terminology. Initial conditions. Initial conditions can be thought of as the starting value on the graph, the value of y when x is 0. So if you have a graph that looks like this, the initial conditions would be the y value at this point. The rate of change can be thought of as the steepness and direction of the graph, and we talked about that in the previous lesson. The larger the value of the rate of change, the steeper the graph. And whether it's positive or negative tells you the direction. Positive, it's increasing like this. Negative, it would be decreasing, going in the downward direction from left to right. So let's take a closer look at the models of the delivery companies from the warm-up. So we have Donnie's Deliveries and Susie's Shipping. They each have an equation. And you already made a graph. If you still have the graph, you can use it to answer these questions, but it's not required. What is the starting price for each company? Well, you can find it on your graph, but you can also find it in the equations. Donnie's Deliveries starts at a cost of $3.50 and then increases by $4.75 for every kilogram. Susie's Shipping starts at a price of $5 and then increases by $4 for every kilogram. So Donnie's Deliveries has a starting price of $3.50. Susie's Shipping has a starting price of $5. How are these initial conditions represented on the graph? Well, if you look at the graph, you'll notice that these are the y-intercept. So Donnie's Deliveries crosses the y-axis at 3.5. Susie's Shipping crosses the y-axis at 5. So the y-intercept is the initial condition. What do the slopes represent for each company? Well, if you look at your graph, you could figure out the slope or the rate of change by how we did in the last lesson, where we're looking at the rise divided by the run, and you'll find that for Donnie's Deliveries, it's $4.75 per kilogram. Susie's is $4 per kilogram. You can also find that in the equation. So they represent the price per kilogram, so how the price changes as the mass of the package changes. Right, example 2, water is draining out of 2 large containers. The relationship between time and volume of water in each container is shown by the following equations. So for container A, this is the equation that represents the volume as a function of time. And for container B, this is the equation. Okay, so V represents the volume, T represents the time. Graph both equations on the same grid. So pause the video and graph that in Desmos. when you do that, you'll notice that both of your graphs for container A and container B both look something like this shape. That's a parabola. So what type of relation are these? Well, these are quadratic relations. We can tell by the shape of the graph. It's a parabola. Determine the initial conditions for each container using the equation and the graph. Okay, might be easier for you to look at the graph first and then see where you find that in the equation. Well, any way you do it, the initial conditions are here. Okay, so the initial volume for container A is 600. The initial volume for container B is 490. Which container empties at the greater rate? How do you know? Well, you can look at the graph and you can see which one empties at the greater rate by looking at how quickly the volume decreases over time. The other thing too is you can look at this number, the coefficient in front of t on the second term. Whichever number has a larger value empties at a greater rate. So we would say container A empties faster because you can see it has a greater rate of change than this one. And here's my last example. A company tests 4 different water bottles for their insulating properties. They fill the bottles with hot water and record the temperature as it cools. Okay, so you got 4 different bottles. Each has an equation that models the temperature. Each exponent is an n. N represents the number of minutes. T is the temperature in degrees Celsius. N is the number of minutes. You have an equation that models the temperature change for each of the 4 different bottles. Graph all equations on the same grid. What type of relation are these? Well, I think you can type these into the Desmos graphing calculator. If you have trouble with that, just reach out to me and I can help you with that. So what type of relation are these? Well, you can tell by just looking at how the equation is written. Our variable is in the exponent. This is an exponential relation. You can also tell by the shape of the graph. Each graph will, you'll get a shape like that. That's an exponential curve. And it just shows you that the graph is an exponential relation. Determine the initial conditions for each bottle using the equation and the graph. So you can look at your graph and you can find the initial conditions. But you can also look at the equation. 75 plus 20. The initial temperature is 95 degrees Celsius. For bottle B, 60 plus 20. The initial temperature is 80 degrees Celsius. For bottle C, 95. And for bottle D, 80. So if you add those 2 numbers in your equation, you end up with the initial conditions for your graph. Now, which bottles cool the fastest or the slowest? Well, to answer that question, you can look at the graph and see, or you can look in the equation, look at the numbers in here. These are the growth or decay rates. Here, we have 0.9 in A and B, and we have 0.75 in C and D. So decays the fastest means it goes down by more each time. So you're looking for a lower number in here for decay. So C and D cool the fastest. The slowest would be A and B because they have the same rate of cooling. Which part of the equation affects the rate of change? Well, I showed you this part in here. The graphs eventually approach a common temperature. What is the significance of this temperature? Well, if they're all cooling down to the same temperature, That just means that's room temperature. So we've looked at different kinds of relations, linear, quadratic, and exponential, and we've been comparing relations within those. So hopefully this gives you kind of an idea of what you can do with it. Try the practice questions, and if you need help, just let me know and I'll do my best to help you.